6.3b. All right, we're continuing parametrics, but we're going to do some lines and line segments, so types of lines. All right. What we're going to do is we're going to be given 2 points, and we're going to be asked to write our own parametric equation for the line that goes through those 2 points. Okay? You can do that in rectangular form. If you're given 2 points, you know how to find the equation of a line, right? Mm-hmm. I'd hope so. I'd hope so. Yes? Yes. Okay. But now we're going to find a parameterization of the line. So here's what it's going to look like. For x, it's not bad. It's actually pretty easy. X and y are going to be kind of separate things. So you're going to start with x1 plus, and you're going to give x kind of its own slope, which is x2 minus x1 times t. Okay? And then the other part would be y, and y equals y1 plus y2 minus y1 times t, where x1, y1, and x2, y2 are 2 specific points on your line. Okay? And there are going to be 3 different types. So you're going to need to memorize that. And I don't think that's that hard to memorize, because you can think of this as the slope of x, and that's the slope of y, or the change in x and the change in y. Sometimes they'll write it like this. I don't know if I should. I don't want to confuse you. Well, I'm going to do it anyways. So x1 plus delta t, like delta sub xt. You like that at all? Mm-hmm. No, let's not. Yes, very physicsy. Pretend like that doesn't exist, and then don't tell Edlin I did that. Okay, here we go. So that's going to be it right there. And there are going to be 3 different types of lines. I'm going to put lines in quotations because they're not all lines. So if I asked you to do this formula doesn't change though. Okay, this formula is going to stay the same. What's going to change are going to be the values of t. Now, if it's a line, what do you think t is going to be? What values of t am I going to use? Negative infinity to infinity. Right? Think about a line. Does a line ever stop? No. It goes in both directions. Now, if it is a line segment, do you know what a line segment is? It has a start and it has a stop. Okay? So what you would do for a line segment, this formula works when t is from 0 to 1. And don't change that. It's not 2 to 5. It's not whatever. It's always 0 to 1. So you plug in 0, you'll get the first point. And if you plug in 1, you'll get the last point. And that's it. Line segment. And then there's one other one, which is a ray. You know what a ray looks like? So that would be, what do you think it would be? T would be greater than or equal to 0. It goes to infinity, yes. But t would be greater than or equal to 0. So it doesn't have a bound on the other side. You could write that if you wanted to, like this. Yes, 0t infinity. But I don't really like that. Do you? Do you like that? Okay, take it. All right, so let's do one. Here we go, number 1. All right, it says here we are going to find a parameterization. Find a parameterization. I hope that's the longest word you write today. Will it be? Probably not. Probably not. Oh, use that in your essay somewhere, okay? Find a parameterization of a line, okay, that's important, of a line through the points A, negative 2, 3, and B, 3, 6. Now, it does kind of matter which one's first, you know, in this formula because there's subtraction going on, and we know subtraction is not commutative. But just think of A as the first number, x1, y1, and B is the second point, x2, y2. All right, so we're going to use this formula, and we're going to write our own parameterization for this line. Here we go. X equals. All right, so A, this is our first point. So I'm going to go -2, okay? And then to find out what the change in x is would be to take x2 over here minus x1 over there. So what's 3 minus -2? 5. So plus 5t. Do you see what I did? This is right here, this is x1, y1. And this over here is the point x2, y2. All right, now let's find y. Y would then equal, take y1, always take this first point, so it's going to be 3, and then take the difference of the y's. 6 minus 3 would be 3t, and that would be worth 2 points, but the question's going to be worth 3, because then I need you to tell me what t is. This is a line, so t would be from -infinity to infinity. And there it is. That's the parameterization for the line that goes through those 2 points. We could find, you know, a rectangular equation by doing either whatever, if you want to do slope form, point slope form, or you could solve for t here and plug it in and find out what y is. You can do it that way too. What are you doing, Chung? You look so happy. Yo-chan's not, though. Are you beating him in some game you're playing right now? Okay, here we go. Number 2. Because I know this isn't making you that happy. All right, let's go ahead and find a line segment. A line segment through the point 5, -7, and b equals -2, -1. All right. I'm going to let you try this. Are you ready? You ready to try this? You can do it. Use the formula I gave you. Find a line segment, and then make sure you tell me what t is. Okay? Did you get it? Let's see. Here we go. X equals y equals. Sometimes I do it this way. I go and I put the 5 here and the -7 there so I don't get them mixed up. So I know that's x1, that's y1. And then I subtract -2 minus 5 is -7t. -1 minus -7 is what, 6t? Okay? And then it's a line segment. So nothing changed until right now when I have to tell you that t is from 0 to 1. Don't forget that. You'll get a point marked off for that because it's really important. Because if you didn't tell me a t, then I assume that it's -infinity to infinity. But this has t equals 0 at this point, and t equals 1 would be that point. And if you don't believe me, plug them in. Plug in t equals 0. What do you get? 5 -7. Plug in t equals 1. You'll get -2, -1. You get those points. Yeah? Okay, so a segment has endpoints, and a line has arrows. The equation will be exactly the same. It's this that changes. Yep. So, in the problem? Yes, line segment and line. Yeah, they have to tell you that, or else you're like, what is it? Okay, last part. Number 3. Last one. Are we going to be able to do it? We'll see. Yes. Look at the time. It's run away from us. Okay, this last one is an interesting one. We're going to use our calculators, and we are going to graph. That's a 7-minute bell. Graph x equals 3 minus the absolute value of t, and y equals t minus 1, and t is from -5 to +5. We're going to graph this, and then I'm going to ask you some questions. I know, right? Not personal questions. That would be rude. All right. I'm going to ask you to A, find the values of t that make up your graph in quadrant 1. Values of t for quadrant 2. And then quadrant 3, quadrant 4. Okay? We'll just stop right there, though. We'll see how far we get. All right. Yeah? What was it? So first of all, you're going to graph this on your calculator. And we're going to see what this graph looks like. So make sure you graph it right. Graph it with these x, this y. Make sure you change t also. So 3 minus absolute value. Do you remember where absolute value button is? Math, num. Absolute value of t. Ooh, what if I left it with cosine? That would be, might be pretty cool. Can I do this real quick? I was expecting so much more. Okay, probably if I change that, huh? Okay, and then the next one would be t minus 1. And then I want to go to my window and change my t values, -5 to 5. So let's all do that. Let's all get to here, and there it is. Okay? All right. And we can graph this. If you want to, hit trace. So t equals -5, and you can get specific points here, which is really important. T equals -5 gives me the point -2, -6. So I'm going to graph -2, 1, 2, 3, 4, 5, 6. That's t equals -5. Best day ever, Trung. T equals -5 is right here. And then we can move along this, okay? So t equals -4 would be my next value. I don't have to plot them all. T equals -3. Ooh, that's going to be important because that's right on the y-axis there. T equals -3 gives me the point 0, -4. 1, 2, 3, 4. Okay? And then we can move along, whatever. T equals 0 gives me the vertex, which is at 3, -1. Okay, so here's my graph so far.
Can't you just mirror it after that?
Yeah. Don't draw arrows, though. And then, yeah, I'm just going to plug in t equals -5, or t equals +5, and find out my last one, which is -2, +4. It's not a reflection over the x-axis because our vertex is at -1. And that's it. All right. You got the graph down pretty good? Okay. Now it asks me, what are the values of t that make up quadrant 1? Okay. Here's quadrant 1 right here. And I want to find out the values of t that are going to give me just that little line segment there. And I actually drew it a little bit too far.
So is it just 0 to pi over 2?
No, no pi's, no pi's. So let's find out. This is what I would do. You have your calculator, okay? You can kind of do a little guess and check, trial and error. I would go ahead and plug in t equals 1. If you plug in t equals 1, do you see where you're at? You're blinking right there. I didn't really draw this that great. You're blinking right here on the x-axis, okay? And then if I plug in, so that was what, t equals 1? If I plug in t equals 2, I'm still inside quadrant 1. T equals 3, I'm right there on the y-axis.
You could always just go to the table.
Table 2. Table works too. Exactly. And you can see when both x and y are positive. You like to do that better? Let's do that. If you go to the table, you'll see that t equals 1 gives you 2, 0. T equals 2 is 1, 1. And then 0, 2. And then it changes to negative. So when both x and y are both positive, you're in quadrant 1. So what t values give me quadrant 1 would be 1 to 3. Now, I did not include 1 and 3. How come?
Because they're on 1.
Perfect. Did you hear them? Because they're on the axes. When you're on the x-axis, you're not in quadrant 1. You're about to, or maybe not, right? So from 1 to 3, you are in quadrant 1. Now, what about quadrant 2? Quadrant 2 is going to go from here to there, not including this, but it does include that. So those would be what values of t? from t equals 3 to 5. Now I included 5 that time because yes, it's in quadrant 2. When t equals 5, I'm sitting right here in quadrant 2. But at t equals 3, I really need an open circle there. Not include that one. Okay? It's a little tricky, huh? What about in quadrant number 3? Quadrant 3, my t values would include t equals -5. And it would go until t equals, what was t there? Was it -2? Was it -3? It's -3. T equals -3. So that would be from -5 to -3. And then last part, part D, what about quadrant number 4? Quadrant 4 is going to be from here to there. So you had to make a little like that. Open circle. And that would be from t equals -3 to t equals 1. Perfect. And that was it. Oh, I don't like that. Nice. Okay, see you tomorrow. Assembly tomorrow.
Hey, you.
Hey, you.
Fill this out for me, please.
Love to. What are you going for?
President. I know. Following in your footsteps.
I was not president. No.
Oh.
Good. Who's running against you? Do you know yet?
No, but
Oh, okay.